Hey guys, another circle theorem proof here. So this time we want to prove that the angle subtended by an arc is twice the angle at the circumference of the circle. Or if we have this arrowhead type thing inside of a circle where there's two radii going from the centre to the circumference of the bottom, we want to prove that that angle in the centre is twice as big as the angle at the circumference. So again, it's quite a nice proof. So we're going to start off by drawing another radius from the centre point up to the angle at the top. Now in doing this, we are creating two isosceles triangles. This is a very common feature of circle theorem proofs. Most of them rely on isosceles triangles. We know they're isosceles because this line, and this line are all a radius of the circle. Now, that's not to say that they are the same isosceles triangle. So what we're going to do is label their angles. The left hand guy, we're going to call his angles A. And in the right hand guy, we're going to call his angles B. And that leaves us with our two missing angles in each triangle. So if we look at the left hand triangle, then we've got 2A. Now 2A plus this third angle are going to equal 180. So if we call this third angle X for now, we know that X add 2A equals 180. And then if we take away the 2A, that tells us X is equal to 180 minus 2A. So that angle, the third angle in the left hand side triangle, is 180 minus 2A. I'm not going to write it in there because it will get messy. Very similarly then, the third angle in the right hand side triangle will be 180 minus 2B. Now let's work out what we're trying to prove. We're trying to prove then that this angle here, let's call him theta. Theta is a cool thing for our angles. We're trying to prove that that angle is twice as big as the angle above it on the circumference. So mathematically, we're trying to prove that theta is equal to 2 lots of A plus B. Okay, so that is our mission. Okay, so we use the angles around the centre point to do this. So if we add them all together, we know that angles around a point add up to 360. So we've got theta, add 180 minus 2A, which is the third angle in the left triangle, and then add 180 minus 2B. Now we know that that's all equal to 360. They are the three angles around a point, so they add up to 360. Now if we sharpen up the left hand side a little bit, we've got theta, add 360, minus 2A, minus 2B is equal to 360. Then what we can do now, quite happily, we've got a common factor of a common term of 360 on both sides. So we take him away. That will give us theta minus 2A minus 2B equals 0. Then if we add the 2A and add the 2B, because they're both negative, we're going to get theta equals 2A plus 2B, which then the right hand side has a common factor of 2. So we can write theta equals 2 lots of A plus B. There we go, we've proven what we wanted to prove. We can always put a cheeky little QED at the bottom of a completed proof for quite enough done.